Okay, so we are in Generalized Linear Models with examples in R. We're just starting Chapter 3, Question 1. So, the standardized residual, R prime sub I, measures the reduction in the residual sum of squares divided by the variance here, okay, when observation I is omitted from the data. Okay, so in other words, we measure residual sum of squares and then measure it again, omitting observation I, and then look at the change in residual sum of squares. Okay, and so we're going to demonstrate this in lungcap here. Okay, so first we're supposed to fit a model that we're calling LC.lm, and this is given to us earlier in the chapter, so we'll just take it verbatim from that. And so we're going to compute the residual sum of squares on that, as well as the variance, and then the standardized residuals from the model. Okay, and then we're going to omit observation 1 from the data, do the same thing, okay, fit the same model, but just without observation 1, and we'll call that model LC omit 1. And then we'll compute the difference between the RSS for the full model, for this model, and for the other model. And then we will show that the difference in the residual sum of squares divided by the variance is the same as the standardized residual for observation 1. So that's kind of a mouthful, but we'll walk through it. And then we will do the same thing for every single observation in the data set. Okay, so first we need to load the GLM's data package, and because this data is in there, okay, and we need to load it, and then we're going to process the data just like they do in the book. So we're taking the variable that is incorporated into this data, and we're going to take the smoke variable, and we're going to turn it into a factor. Okay, so this is what the first several columns, or I'm sorry, the first several rows of our data looks like. Okay, so we're at the first part here. So we're going to fit the model, and that's given on page 97 of the book, and then compute the residual sum of squares, and the variance, and the standardized residual from the model. Okay, so here's the model. Okay, now I can take the residuals from the model with resid here. You know, I wish you didn't have to run the whole block in order to see what these commands did. So if I take that, so this is every observation. This measures the residual for every observation. In other words, we fit the model. The model therefore predicts something given the height, gender, smoking status of that particular observation, and the model is off by the actual observed value by these amounts here. That's what's going on there. Okay, so you see that there's a lot of them, one for every observation. Okay, so if I want to take the sum of all of that, or so if that's the residual, I want the residual sum of squares, the total sum of squares. So first I need to square that. Okay, square that guy, and then take the sum over all of the observations, and so that's what we've done here. Okay, and then to get an estimate of the variance, we can do this in a few ways. One, we can just take the variance of the residuals, okay, or we can take RSS, the residual sum of squares, divided by the number of observations minus the number of parameters. Okay, so this is this. Okay, and so I've already ran that here. Okay. And so here you see the residual sum of squares, and then the estimates for the variance. I'm not sure why there is that slight discrepancy. Actually, I may have some error in here, but it could also be just rounding error. I'm not really sure. But anyway, so now we want the standardized residuals, and so the way that we do that is with this rstandard command. Okay. And so now this is going to give me, again, let me just run this over here so you can see what this command produces. Okay, so we run that, and we get a bunch of residuals again, but now these are the standardized residuals. Okay, so I can take the sum of the standardized residuals, just like we did above, and then calculate the variance on those residuals in the same way. Okay, and this is what we get. Okay. So at any rate, so we can do the same thing for the standardized residuals here. Okay. So now we're going to do the same thing, but on a different data set. Well, a truncated data set. So we're just omitting observation 1. Okay. So we're going to compute the residual sum of squares for the full model and for the omitted data model. And we're going to take the difference and then the difference in the residuals between the first model and the omitted data model, and then divide that by the variance. Okay, and we show that that is the same thing as the standardized residual squared for the full data model. Okay, so I've ran all of that. Okay, and so so here we see the difference in the two RSSs between the two data models. And then this is that difference divided by the variance. And then that difference, I'm sorry, not that difference, but now the R calculated standardized residual squared. Okay? And you notice that this and this are equal, just as we're told it's supposed to. Okay? Now, if it's not really clear why that relationship should exist, okay, you might want to ponder this expression right here. The difference between these two things divided by the variance is just simply the definition of the squared residual, the squared standardized residual. Okay, so okay, so now we are supposed to repeat that process, but for every single observation. And so that's what we'll do here. Okay, so so this is similar code, or I think actually the same code from above, but what becomes important is this for loop here. Okay, so this for loop is going to go through every observation and do basically what we've done right here. Okay, and then every time that we get a difference, or every time that we calculate the omitted, we will subtract the non-omitted and the omitted RSSs, and then we will put that into this vector, which we've defined ahead of time before the for loop runs. Okay, and then for each one of these, right? So we'll get one entry for every observation, and then we'll just divide them all by the standard by the variance, and then we'll just look at them. Okay. So I guess I've already done this and run it one more time here. Make sure the code's operating. Okay. And so what we get then is our hand calculated standardized residual and the one calculated by R. Okay. And again, if you just go across these, you notice that they're all the same value. Okay. So we'll call that good.